Welcome to Accelerate Science Now, where we sit down with innovators shaping policy, research, and industry to ask one big question. How do we make science move faster and work better for everyone? Today, I'm joined by Anastasia Gamick, co-founder and president at Convergent Research, where she's pioneering focused research organizations, or FROs, a new funding model aimed at accelerating scientific progress. We talked about what inspired the idea, why traditional institutions can't always take big bets, and how new structures can help unlock breakthrough discoveries. Enjoy the show. Today's guest is Anastasia Gamick, the co-founder and president of Convergent Research, where she helps pioneer new institutional models to accelerate scientific progress. Convergent Research is best known for launching focused research organizations, or FROs, mission-driven, time-bound nonprofit teams designed to tackle critical scientific and technological bottlenecks in areas like biomedicine, biosecurity, and climate technology. Before founding Convergent Research, Anastasia was the first operations hire at Neuralink, served as chief of staff at the robotics company Creator, and led the rapid scale-up of COVID-19 test production at Curative. She brings deep experience from fast-moving technical startups to reimagining how large-scale science can be organized, funded, and translated into impact. So, Anastasia, thank you so much for joining us today.
Yeah, it's really great to be here. I'm excited.
Awesome. Well, we always like to start off with a little personal getting to know you better, and wanted to ask if there's anything specific, growing up or early in college that made you know you wanted to pursue a career in science and technology.
Yeah, I grew up in Pasadena, California, and so all of my friends' parents were astrophysicists or movie producers, and so I thought that was the only two options for an adult, is you can go into be a movie producer or work at Caltech. And it didn't occur to me that it wouldn't be normal to grow up to be an astrophysicist, and so I just spent my whole life um, loving the cosmos and being enthralled with science. And then it turns out that I actually don't like formal math. I
Mhm.
am not a huge fan of like differential calc.
I'm guessing
And
that's
so,
pretty necessary for astrophysics.
yeah, yeah, I only made it part of the way.
All right, but did start a love for science, and that's all you needed to get going. So you've worked at a ton of really interesting institutions and companies. So Neuralink, Creator, Curative, all fast-paced, high-stakes tech environments. How did those experiences shape the way you think about organizing scientific teams and solving hard problems?
I think that there are a couple things that really stand out to me. They're focused and goal oriented. You have to get to this demo, you have to get to these metrics. And everybody's kind of like, is the thing I am doing the highest priority thing against that goal that I could be doing in this moment or in this week? And so it really helps remove outside projects or things that are not as important. Um, and then they're cross-disciplinary. You have software engineers and product managers and hardware engineers and EEs, and all of these people are working on related pieces of the same project, and they all have to be coordinated. And so it was just kind of amazing to see how much could get done in very short amount of time with everybody that focused and working together using good practices. It's been really cool to watch all of these things get built over the last few years.
Got it. And those, yeah, each one of those companies I know is focused on something really different, but that seemed to be the overarching thing that they had in common, was just that intense focus.
I think that that's generally right for Silicon Valley startups, right? It is a group of people, sometimes less than 25 people, going 0 to 1, where they're really focused on how do we build what we need to demonstrate to our investors that we uh, are justified in raising our next round? How do I get the customer acquisition? How do I get the technical hurdles done? And so you're so focused on actually the outputs that that's what matters.
Hmm. Got it. And so it seems like a pretty big jump to go from these very fast-paced tech startups to founding Convergent Research. Can you talk about like what happened there? What inspired you to do this? What made you make that change?
Um, yeah. So most recently, I was working for a startup that was doing last mile payment delivery across sub-Saharan Africa. So I was helping big NGOs, the UN, send payments directly to beneficiaries in Nigeria and Uganda and the DRC. And that startup got acquired and my life got very boring. Um, it sometimes happens when the mission is no longer quite as important. And I started thinking about what would be the most impactful thing that I could do with my career. And I was really kind of interested in in things around biosecurity, uh, climate tech, neurotech, because I think that these are all big problems in our society. They're big opportunities. They're places where there's like strong technical progress that could be made. And I was looking for bottlenecks and projects that I could run, and I was really inspired by a podcast that Elon Gurr did. Elon Gurr's the CEO of ARIA, the UK's advanced research innovation agency, and was previously the CEO of something called Activate, which was an accelerator that helped helped technology get out of the lab and into the real world. And I was inspired by him talking about sort of institutional mechanisms and how you could help many scientists achieve kind of breakthrough impacts. And so after that, I started just talking to people about what kinds of models would help move breakthrough technologies in those areas into the real world, which is how I met my co-founder, Adam Marblestone. So we started hit the ground running working on FROs.
Okay, great. And so, for any listeners who are not familiar with FROs, focused research organizations, can you explain? I mean, you kind of had the perfect setup of solving bottlenecks and needing a new institution, but what exactly are FROs? What is the purpose behind them?
I think our thesis is basically that we've prematurely standardized on um, a series of different ways to do science and R&D in the U.S. You know, we have university researcher-driven, individual-driven research, and then we have startups, and we have industry labs. I guess we have a little bit of DARPA, and we have some national labs. But those are kind of the ways that we do science, and not all kind of R&D or science problems cleanly fit into one of those buckets. And so that is where this concept of a focused research organization comes from, that there are problems that need multidisciplinary teams all working together. There's a very clear roadmap of how you will get to this product that would solve a bottleneck in science. They are usually, 5 to 7 years, something between $30 and $70 million. They're medium scale efforts. They're more than a single R01 or a single academic grant, but they're not for-profit venture backable efforts. They're often generating
Mhm.
public goods, or they're maybe generating tools or diagnostics, things where you can't recoup the investment in the same way. So you can't do it as a for-profit. And so for these organizations that are building these, or for these ideas that are transformational ideas, but can't be done in an academic setting, they can't be done in a for-profit setting, we propose the focused research organization.
Got it. Could you give an example of a scientific problem that really requires that kind of in between solution?
Yeah. So my co-founder, Adam Marblestone, is a physicist by training, and then he was a neuroscientist, and he was really interested in kind of the big problem of how do you map a whole mammalian brain at a synaptic level? How do you actually see what neurons talk to what neurons across a whole brain? To do this probably would take decades and would cost, they estimated, billions of dollars, which is kind of a non-feasible way to run this project. But you can build the technology to make that cheaper using expansion microscopy, using molecular barcoding. And so these are all things that happened in an academic lab. There's somebody who wrote the paper on rainbow and this molecular barcoding, and there's somebody who did expansion microscopy work. So they all happen in an academic setting. And then
Hmm.
could you industrialize that? Could you grow that to a tool that someone could then use reliably to be able to generate synaptic maps at scale? And then with that tooling, you could then go and do the full mammalian brain. And so that is a project, that like tool development project, that process development project, was never going to happen in academia because it's actually like a bad dollar to paper ratio. They actually just released a paper called PRISM. It's the first paper on molecular barcoding and on proofreading these neural maps. But if you're in an academic setting, you actually need like a paper per grad student and a paper per postdoc every couple of years, every 6 months or every year. And they spent three years developing this technology. It's now this really beautiful, robust technology, but it isn't set up to be done in an academic setting.
Got it. It's just not fast moving enough or not enough like publishable results at a
It's
quick pace.
it's too big. It takes too much engineering.
Mm.
Oftentimes, academic papers happen. You do just like the next incremental thing so that you can publish the paper. And then you do the next incremental thing, and you do it once. Because we want to do this at scale, we actually need to be able to do it reliably hundreds of times in a row or thousands of times in a row. And so that engineering problem, the mechanical engineering problem, the chemistry problem, that's not something that an academic lab would do because they're not incentivized to get really good at doing the same thing over and over again. They're incentivized in doing something new each time. But to map a whole mammalian brain, you actually need to be able to do it many, many, many times in a row, reliably the same way every time.
Wow. Okay. And so, can you give some exciting examples of what you can do once you're able to map a mammalian brain?
Yeah. So I think that one of the cool things is that we don't actually know because we've done this we've done like a cubic millimeter with an
Hmm.
electron microscope. Um, but so we've never done a whole mammalian brain, but you can imagine if you were studying a computer or a building and you didn't have the wiring diagram, you wouldn't actually know how that system worked. So this is
Hmm.
be like pulling out the wiring diagram for a brain. And so you could do things like you could look at actually what are the signal pathways for neuropsychiatric diseases. You could think about emulating brains. You can think about how brains work when you're looking at designing AI systems. There's a bunch of different uh, medical applications. There's like fundamental science applications, and there's AI and computer science applications as well.
Wow. Okay. So, is this one of the FROs that Convergent Research has launched?
Yes. Yeah. So E11 launched in 2021, and they just released the first preprint a couple weeks ago. And they're a team of less than 20 people in Alameda, California. They stood up their own lab. They have their own company. They're run by a CEO, Andrew Payne, and they're chugging towards kind of these like transformational tools and technologies.
Great. And so, can you give some examples of other FROs that Convergent Research has launched? How many are there at this point?
There are 10 in our portfolio right now. We're in the process of launching one or two more in the UK with ARIA. Let's see, a couple of the ones in the US. We're really kind of area or application agnostic.
Hmm.
There's this program called EVE, which is a high throughput drug screening project. We're basically trying to map the pharmome. So we're looking at a bunch of FDA approved drugs and then the druggable target. So actually, what are those drugs interacting with in the body? This data set seems really basic, but it actually isn't available. We've been doing data releases for the last year, and we've already released the most interactions that anyone's open sourced. And we have another 3 years of this program to keep open sourcing data. With this, you could see what like secondary targets are being hit. So maybe like what's causing side effects, what are potential downsides of drugs. You could also see what other things they could be used for repurposing. So what else could this drug treat? And you could use it when training different AI models. You could use it for drug discovery. I think it is a fundamental data set that will change the way we look at pharmacology. So
Oh,
we have that
yeah.
project. We have projects across climate space. We're working with a math project. So it's an open source language for formal math. It is basically letting computers do advanced math, the kind of math that I don't want to do. But letting computers do the state of the art math that mathematicians at universities do, and they're able to check their work, or their computers are able to do. They're improving on their own. We have projects we're building a big telescope in Chile. So the idea is that we're actually agnostic to the space that we're working in, but more that these types of problems are problems that are hard to do in academic settings. Universities struggle to do projects that look like this, and so it's often complementary to university work.
Got it. And so these do seem like they would turn out results that could be really profitable or that a lot of companies would be interested in purchasing. So how like when the FRO sort of completes its job, then what? Like do they turn into a company? Do companies like acquire that information? What happens then?
It's much like a university. They'll generate IP, and so maybe somebody will license that IP. Maybe it spins out into a standalone nonprofit that offers a service. Maybe it's just this open source software language is an open source language, and it will continue to exist the way that Python exists. Where everybody builds on top of a program, but it's a program that's maintained by a nonprofit.
So sounds like it could be very dependent on what the FRO is, and you have so many different ones.
Well, I think that this is one of the reasons that we're working in this space is that there's a lot of we're looking for what's most impactful for the science. I think that we had to figure out how we thought about tech transfer and how we thought about IP, and really building it again from the ground up in a way where each project could use the exit that would be most impactful for that project.
Interesting. And that kind of brings me to my next question, which is how does Convergent Research decide what to work on? Like, do you put a call out for, we want to do something in this area and let people submit, or is it more
So,
intentional than that?
so we've done all sorts of things. So a lot of our work is done by talking to this process called scientific road mapping, where we spend time in a field talking to experts, um, running workshops, looking for what the most impactful kind of transformational technology in that field would be. So we spend a bunch of time in neuroscience, we spend some time in computer science and math. We also have worked with ARIA in the UK. They have a series of opportunity spaces. That's how they've organized their work. And then we've done an open call within those opportunity spaces. So we're aligning with government priorities to figure out what we think the most impactful projects would be, and then are working with those teams to fully develop projects, hopefully to launch, aligned with kind of what they would like to be doing, with what the UK government would like to be doing in those spaces.
Got it. And it's really exciting you're working in such close partnership with the UK government. I noticed that the AI action plan that the Trump administration released earlier this year included a specific call out for focused research organizations. Did you guys do that? I'm sure that was really
Uh,
exciting to see included in
I'm
there.
I'm extremely grateful to see it in there. No, it's a thing that we've been thinking a lot about is if AI goes well, what will make that happen? So, for AI for science, it could be
Mhm.
things like, well, what are the best data sets that actually you need in order to do really good AI-driven science? Um, it's not clear to me that companies or academic labs will actually do the wet lab real world research that then you could train models on.
Mhm.
Or it could be that there are very specific things that need to be built. Um, an example could be a formal verification, which would be very useful. So I guess one of our worries about AI is that actually it will increase the ability to commit cyber crimes or cyber warfare and to hack other systems.
Of course.
And so you can build better defenses. You can build formally verified software. So the idea being that you could build software where you can prove that it can't be hacked in certain ways or it can't be attacked in certain ways. And so this would be a project that we could do standalone as an FRO to build that capability. And so I think that when the AI action plan is referring to FROs, it is thinking about what are the ways that you build very specific projects that we think would move the direction of how AI is being developed and used in the US.
Interesting. So not exact, yeah, less like just general science impact focused than what Convergent Research is doing, and much more focused on AI.
Yeah, or Alternatively, if you wanted to do the best projects in science with AI, what would they look like? So I think that one of the things about FROs is we spend a lot of time thinking about what is the highest leverage thing we can do in a space. And so figuring out those high leverage options.
Got it. And so, just talking more on like possible partnership with US government, where would you envision like if the US government wanted to, have a program like the UK's ARIA and invest in focused research organizations, where would that fit? I mean, you mentioned earlier there's so many different parts of the science apparatus within the US government.
Yeah, I think I've been thinking a lot about this idea of building the performer. So let's say um, if you have a DARPA program, you have this whole ecosystem of performers that came up with that DARPA program, right? You have Boeing and Raytheon and all of these different companies who got very good at bidding for and performing against certain types of DARPA contracts. But if you look at something like ARPA H, there's not actually a bunch of contractors who all can do biology research. Or if you look at a new priority area like AI or quantum, there's not necessarily somebody out there who can do the exact research that you want to do. And so the way that Convergent or that FROs can interact really well, I think, is if you were to say, I want to run this project with these results, we can actually stand up an entity or a company to perform against that. We can create a performer that does actually what the whatever that funding agency wants to achieve, rather than trying to pull academics or ongoing biotech researchers off of whatever their inherent motivations are, whatever they're doing in their lab or whatever they're doing in their company, to try to get them to perform against a government contract. We can actually just stand up a new entity to do exactly that thing.
Interesting. And where would you find the people to be in that entity? Like where do you find the the scientists?
So generally what we do is we spend a bunch of time looking for the senior leadership, usually something like a CEO or a CSO, somebody who has a vision in the space, it's clearly technical, who can lead a team. And we work with them to design the proposal and the organization. And we've actually found that then hiring the rest of the staff is like remarkably easy, because these are some of the coolest projects that you could be working on. Scientists love to work on like really hard problems, and they're paid, market salaries, they're paid industry salaries. It's better than academia in performing the work. They get to move fast. They get to work with a team. And so it's actually been really easy for us to stand up teams of 5 to 25 people to tackle these goals.
Got it. And another thing I've read in about the FROs is a unique part of them is that they're time bound. Can you explain like what that means and the reasoning behind it?
Yeah. I think oftentimes when you stand up a new institution, you are implicitly or explicitly saying that you'll fund it for forever, or that someone
Mhm.
will fund it for forever, or it now has to enter this rat race of raising funding for itself next year over and over and over again.
Mhm.
That's like not our goal. And instead, either for a funding agency or against one of or for one of our philanthropic funders, we say, hey, here's a clear fundamental capability is often what we call it. Here's a product that we think that we should build, that we think will accelerate science. We'll build this brain mapping technology. We will build this big data set. We will build this modeling tool, whatever this fundamental capability is. And what we say is going to cost us X million dollars and take us Y years. And that's it. We're actually like selling the thing that's on the end of it.
Mhm.
And we're pitching funding that full project and getting it done, rather than standing up a new institution where every year they're going to have to set next year's goals and then go out and fundraise again. So rather than letting the mission be driven by where someone can get funding, set it up front, set very clear milestones along the way, see whether or not we're going to achieve it, and then go and build a technology.
So for these different FROs, do they each like how do you come up with what the proposed timeline is? Is it working with those scientists and like trying to figure it out for each one individually, or do they all have a kind of general 5 to 7 years?
I think we're looking at these mid-scale projects. We're not looking at things that could be done in a year with a small team. We're also not looking to build Fusion and have it take 30 years. We're looking for things that are in this 5 to 7 year range, but then it is a lot of work with engineers and the scientists to actually build out that roadmap and say, what is a feasible time for this to be done in? What do we think the first year will look like in some level of specificity? And then what do years, 2 through 5 look like, assuming that's correct? And then every year working with them on governance and updating those timelines and those OKRs.
Got it. Okay. And that was another question I had is how involved is Convergent Research? Obviously, hugely involved in getting the funding and getting everything started. But once an FRO is up and going or working on their goal, how often are you checking in with
Um, so I would say first that we're not proprietary about FROs. Everyone could do an FRO.
them?
But we have done now 10 of them. And the way that we work is so we're a 501(c)(3), we're a nonprofit. Each of our FROs is a subsidiary LLC. So this is a benefit because, we have a SAM.gov account. We handle all of the reporting and all of the invoicing and all of the pieces we're not, they're very back end and very scalable. And the company itself does the science and the product and the user interviews and things like that. One of either Adam or I sit on their board. And so we meet with them in that sense, where we have quarterly board meetings. We represent often the funder, thinking through if they're hitting their goals and how they're working towards their progress.
Got it. Okay. So still staying pretty involved.
We're
And
we're
so
we're pretty involved. I think that one of the things that is hard with novel institutions is you have to think about what does governance look like? How do you, if you're at a university, actually the system's pretty clear how people are working and why they're working that way. In a brand new startup, I think that there's a lot of work that we do to help make sure that people get out of the gate moving in the right direction, moving quickly, help them solve problems, help them troubleshoot when something goes wrong, help them fire their first team member, help them reorg, help them when they're slipping behind their goals and trying to figure out, is this actually we need to go back to the funder and rewrite these milestones, or should we actually say this is technically impossible? So we often represent the funder in those conversations with the companies as the board member.
got it. That sounds like a ton of work. It sounds like you must just be like really great at operations because that is a huge piece of this. And it sounds like you're almost kind of handling that for the FROs.
So all of the back end pieces we are. So I think that one of the things that Convergent does is that because we've built up the ability to do HR and accounting, and we file our tax returns every year, and we have a legal department, we try to just be a very fast, speedy back-end operator who our funders can trust. So we hold the nonprofit status. We're the ones who are ultimately responsible for hitting these goals. So that way that, funders, whether that be USG or philanthropies, can trust that we're hit the goals without having to trust a brand new organization that just got started.
Yeah, that makes a lot of sense. Great of you guys to do that. Sounds like maybe not as much of the exciting part, but you still get to, you're getting to work with all these different FROs and hear what they're doing. So I imagine it's still, very exciting and inspirational.
I think that I probably have the best job on the planet. I just talk to leaders in a handful of different fields as they're building technologies that I really believe will change the way that the world works.
That's so fun. Can you give any examples of how you think the world is going to change from a couple of the FROs you guys are working with?
Yeah. I'll give a concrete example. So we have a project that's working in neuromodulation. So they are building an implantable device that uses ultrasound to be able to image the brain. So you can imagine an fMRI scanner takes live images of what's happening in someone's brain. When someone has really bad epilepsy, they often have to figure out where those seizures are coming from. And so they have to stay in a hospital bed for like weeks at a time with electrodes in their brains. And it's really, really tough. With this, you could actually have a surgery and then go about your life and get those same images as that the electrodes would have, but while able to interact with your family, while being able to go to school, while being able to work. Um, and I think that this is like one of many changes that will come because of this device.
Wow. Yeah, that's absolutely life-changing. That's really incredible. Convergent Research got started in 2021, correct?
Hmm.
And
Yeah.
so if 5 to 7 years are all of your timelines, are there any that are coming up on, like, finishing with their end goal?
Um, I think that our oldest FROs are about 4 years old right now. Um, E11, which is the brain mapping technology, is one of them, and then Cultivarium is the other. I think that they're both looking for, one of the things that's exciting for both of them is like, what do we do now with this technology? As we've been building it, what comes next? And so I think that they're both actively pursuing partners and funders and business opportunities on the other side.
Got it. Really exciting. And we'll actually get to see more of the, like, being put to use and the actual implications that they're going to have. Well,
Exactly.
that's really
Exactly.
great. Well, I guess another question I had for you, especially since you had such an interesting start with all these different tech startups. Well, I guess for one, is that what you immediately did after college? Was like go straight into startup land?
Almost immediately. If I'm being honest, I bought a one-way ticket to New York, and uh, I graduated during the recession, so looked for jobs
Mhm.
in New York for a while, and then ended up working at startups through that. Right, starting at like back in the Uber days at carpooling startups, and then into robotic startups and
Oh,
and
fascinating.
neurotech.
Got it,
Yeah.
got it. Okay, so I guess what I wanted to ask is if what advice would you give young scientists or entrepreneurs, I suppose, who really want to work on big problems but don't know where to start?
So I I think that one of the things that is really hard for young people is that they often want to work at like the biggest problems, but there's actually a ton of skills that you can learn that are very useful later on. So if you want to be a scientist, there is some amount of like figuring out what you want, going deep, getting training. The same thing with an entrepreneur, like learn how to ship, learn how to finish things, learn how to get things out the door, stand things up. And those skills of actually being able to build something and do something real in the world then are what is most useful when you turn towards the big impactful things.
Got it. And
And
I'm
they're hard
guessing,
to learn when you're doing the big impactful things.
right. And would you say that were there any key lessons that you learned early on in those startups and tech companies that you're still using now?
Yeah, I do think that like if you want to ship and do a lot, you really have to prioritize and you have to prioritize finishing things. I think that it is very exciting to like start lots and lots of new things, but actually like uh getting something out the door, getting it into the hands of users, having people give you feedback on it is like one of the most important things that you can do. Um and so more than just like writing about it, actually building something, getting people to use it. Um I we do that all of the time. We're constantly working on new programs, on, we have a new FRO coming and what if we change the way that we did this? We're talking to a new funder. What if we change the way we did that? And actually trying new things, I think is really important.
Yeah, that constant evolving, always getting better, makes a ton of sense. All right, well, just sort of wrapping things up, looking ahead 10 or maybe 20 years, what do you think success would look like for Convergent Research and the broader FRO movement?
I I think I will judge our success as if I think about our FROs and if we've done something that I call a scaled revolution. So if I look at E11, and we have changed the way that people think about neuroscience. If people are looking at synaptic maps and making new discoveries or doing new treatments, that will change the way that neuroscience is done, um, starting with what E11 has done. If we change the way we think of toxicology because of how Eve works, if we have formally verified software deployed in all of our, critical infrastructure because of how lean works. If I think about those big kind of world-changing ways to apply the science and the technology, that is what a win looks like for us. And then the FRO ecosystem, I'm hoping that people continue to experiment with many different ways to do science. I think that there are right now we have a couple really good ones, but there are other ways to fund within the university system. There are other ways to fund outside of the university system. There are projects that are not being done that should be done. And so going ahead and taking risks on running experiments and how we run experiments, running experiments and how we do science.
Yeah, I mean, relatively, FROs are a very brand new addition to the institutional model. Are you going to keep looking for new ones yourself of different ways, or you think you'll keep focusing on FROs for a while?
I think that we're not done. A little bit like I said, I think it's really important to finish things, to like get it out there, to show that it works, to get feedback on it. And so I think that when, certainly until the first few FROs have gone all the way through and that we're really kind of demonstrated that this model works, this is what I'm going to focus on.
Great. Well, it seems like it's working. Seems like it's gaining a ton of traction. So thank you so much for the exciting work that you're doing, that Convergent Research is doing, and just thank you for joining us today.
Yeah, I'm really happy to. Thank you.
You've been listening to Accelerate Science Now. I'm your host, Adeline DeYoung. The show is produced by Kindred Subjects, Accelerate Science Now, and Seed AI. Our executive producers are Josh New and Austin Carson. Special thanks to Kevin King for editing and production. Thanks for joining us, and we'll see you next time.